Welcome everyone. Welcome to our Bow and Arrow seminar online. I'm David Lapetina. I'm VP of Engineering and Technology at Kyanon Digital, and I will be your host for today. This webinar is co-hosted by Kyanon Digital, which is a one-stop digital services company in Vietnam, and also hosted by Vietnam Datathon, an organizer of hackathon for Vietnamese students. Today, we will discuss about object detection with three parts. The first part will be led by Dr. Bao, who is the Dean of the Faculty of Information Science in Saigon University. Dr. Bao will speak about object detection, the theory, and how different techniques can be used, what are the pros and cons of each technique. After this part regarding the theory, we will discuss together in terms of application and use case in different industry, how object detection can help and leverage your business to provide more time to market capabilities and also a more sustainable business. And at the end, we will have some Q&A. So now, please let me introduce to you our first speaker, Associate Professor Dr. Pham Te Bao. Bao is the Dean of the Faculty of Information Science at Saigon University in Vietnam, and is a leading expert in the field of computer vision. So please, Dr. Bao, I let you the floor.
Oh, thank you very much, David Lapitina. So, thank you for your joining my section. I will present to you the evolution of object detection from classical image processing method to the modern deep learning era. Object detection has become one of the most fundamental tasks in the computer vision, underpinning many real-world applications from the automotion, driving, surveillance system. The journey of the object detection has been transformed, evolving from the handcraft feature in the early image processing today to advanced new neural network. So I have a 5 parts to introduce for you. The first, I begin with the introduce to the object detection problem, where we define the task is important in various applications. This session will set the stage for understanding the problem we arm to solve with a different method. The next, I introduce the classical image processing for object detection. I explain how early techniques like act detection, time matching, and geometry transform. After that, we move to machine learning domain, where we'll say to hold the line viola chon and a feature injection technique so that histogram of orogenic gradient began automating object detection. And then I present the deep learning for convolutional neural network, since CNN, YOLO, finally the DETR, and finally we will end to present by summary of 3 domains. And it in the strength and application. Let's begin with the definition of object detection. It is a core object detection in a computer vision technique that enable the system to locate and classify instant our object within an image or video. This is a fundamental task in many real-world applications where the goal is not only to recognize what is it in image, but also determine where is it. For example, we say the street stand with the people pass cars, its object in the surround by the bounding box, and the box have a label so that the car, dog, and person. In simple term, object detection combine image classification and location. The system must first recognize the object and then draw about the bounding box around. It's the indicator it locates in the image. I cannot move slide. Okay, David can help me to okay. It's wow. Okay, object detection has a broad application that span across a various fields from the early image processing technique. Today, a deep learning model. I want to work you through three major phrase object detection and its respective real-world application. The first on the left, we have an example template matching from classical image processing. In this case, we use predefined image template on the aircraft to detect similar objects such as an airplane or helicopter. Template matching is one of earlier methods used. Next, in the middle, in the example from the machine learning area, we see the violent tone algorithm applied to face and eye detection using hard feature and cascade classifier. Violatron was a breakthrough in the real-time face detection. Finally, on the grid, we see the modern application of object detection power for deep learning is a form to field automated driving, where deep neural networks are employed to detect a surround vehicle. Now, let's take a moment to look at the evolution of object detection over time. This table provides a brief timeline of the key milestones showing the transition from classical image processing to deep learning method. In 1960, we began with the basic technique like template matching. In 1962, we saw the introduction of how transform and fast forward 1986, we have a candy egg detector, a critical tool to detect egg in the image with high influence in classical image processing. And 2000s marked the rise of machine learning in the object detection. In 2001, Viola-John algorithm was introduced, revolution to face detection. A few years later, 2005, the combined HOG and SVM become popular, and pedestrian detection. In 2008, the form park page model to took object detection. Between 2014 and 2016, introduced RCNN family. Reliable RCNN, fast RCNN, faster RCNN, and transformer field enable much more accuracy and scalable object detection. In 2016, you only look at one. It's a yellow. It's a make real-time object detection possible with the ability to detect object. And more recent 2020 introduced DETR with a use transform for object detection. Before the advent of machine learning and deep learning, object detection relied heavily classical image processing technique. The method focus on identifying a low level features such as accent or texture within an image. One of earlier technique is template matching, where section is an image to compare with a predefined templates to find similar object. Another is a house transform, which detect simple geometry shape like line or cycle. Finally, we have egg detection. The method is to identify object boundary by detect change in the pixel intensity. With a template matching involves sliding to predefine template image across the target image to find areas that are closer match the template. It calculates a similar cross. The method works based when the object scale, rotation, and appearance remain constant. Now, let me walk you through an example for detect the medical embryo using template matching. On the left, we have a target image where detect a performance, and in the top left corner, you see the template we are using. Template imaging across the image. We use based on correlation map. And the middle is a red cross indicate the possible match, highlight area where the type is similar with a high. The final image on the right shows the result after non-maximized suppression, where we have successfully detect 4 objects. Timeless matching is simple and work well for the rigid object. It faces significant challenge when object change in the size or orientation with a limited effectiveness. This brings us to how transform. The how transform is a powerful technique designed to detect simple geometry shapes like line, circle, and ellipse by converting image point into the parameter space. On the left, we have examples of street line detect in the autonomous vehicle. The how transform identify the land marking by detecting straight line from the car viewpoint. On the right, we have the example for iris detection, where the circle pattern like the human iris are identified. The how transform is how the finding shape in noise environment and widely used broad line detection and medical image. However, it is computational, expensive, and still struggling with a more complex or overlap set. The candy egg detector is a multi-step algorithm designed to detect wide range of X or image. This method starts with Gaussian blur to reduce noise, followed by Bayesian calculation to measure chain intensity. Let's break it down with an example. On the left, we see on the leaf with the blur background, the first step. Gaussian blur is applied to reduce noise in the image. Next, in the middle, Gaussian calculation is performed using Sobel kernel filter to detect intensity change. Finally, after hysteresis threshold, we detect the promised act of the leaf, as seen the right image where the bounding box is rolled around the object. Candy egg detector is high effective for detect leaf clear. It can be sensitive or noise or require carefully to turn up to parameter. So in summary, classical image processing method with a strength is a relatively simple computational effectively for well-defined task in controlled environment. Classical method struggle for variability for object size, orientation, and appearance. Additionally, their methods are high sensitive to noise, meaning small change in light or texture can severely impact the accuracy or detect result. Classical image processing technique lay the foundation for object detect intellect for flexibility to handle complexity and variability. This shortcoming eventually paved the way for more advanced methods like machine learning and deep learning. So machine learning addresses the challenge by allowing the model to learn features direct from the data. Instead to rely on the handcraft feature like X or template, machine learning model can learn pattern through training, which enable from them detect a wider variety of objects, even in more complex or dynamic environment. Additional machine learning automates to detect the process. This improvement make it possible for detect system for apply the real-time tasks such as face detection in camera or pedestrian detection in autonomous vehicle. Viola John algorithm developed from 2001 marked pivotal moment in object detection. It was the first framework capture detected face in real time. You know, over 25 years from the first problem about face detection, 2001 is the first time face detection become more popular in the camera. So for the algorithm you highlight feature. And the cascade classified the key to speed up this algorithm. The first performance quick scan show in the first image, 3 images where they start with scanning the left side to the head, then the eyes, finally eyes and nose area. The algorithm rapidly recheck area that don't look like the face Continual refine is observed on area that do in the final image the phase detection with the high accuracy. So following Valiant John, another powerful compiled machine learning technique is the HOG SVM, support virtual machine for the tech of pedestrian and vertical. Last up, HOG, check gradient orientation is in the small region called sound. And one of the features injected by the Fed into SVM is binary classification algorithm. The SVM take the SOG feature and classify wherever the particular region contain the pedestrian or vehicle. At the left, it is a full process. The system is first trained data car, motorcycle, and then by SOG, it usually check the feature. This feature is then classified the SVM as an output of prediction. And on the right, we see the result graphics surveillance system record are the detect and green bounding box and motorcycle with the blue ones. HGO combined SVM is very effective. Unlike viral channel or combined SOG and SVM with trick object hold in entity, the formable part place model detect object breaking to down to the part. DMP model the object by the component. For example, in the usual image BSM bicycle, the EPM detect the part of like the wheel, legs, arm, and then combine them to become the possible relationship. Machine learning method brought simulation improve to object detect compared to classical approach. Let's start. First is the method to generate faster than accuracy. Another key strength to their ability to generate by learn feature from the data. Machine learning model capture the detect more complex object. However, this is a concern consider it take high computation cost. Train this model and even running them requires significant process power and memory. Additionally, these methods are still somewhat limited in type and object. Lastly, while machine learning methods are faster than classical approach, many still struggle with the real-time application. In the deep learning area, object detection when the simplification transform particular user introduce convolution neural network CNN revolution object detection by automatically learn feature from the data. One of the first was CNN family with the RCNN 2040. Like later, fast RCNN, faster RCNN, they improved accuracy. In 2016, YOLO was introduced result approach object detection is from the single region problem. YOLO was able to perform real-time object detection with the impressive speed witnessing for field line autonomous driving of video surveillance. So now we have YOLO version 10. It is so fast, accuracy is very, very nice. Another method for the single source multi-box detector SD. And finally, we have a elastic advance with the transform model like DETE. So it is a simplified for object detection highlight. RCNN introduced while apply CNN to object, introduced a concept region proposal. The network is the first generator potential object region. And look at the process with the help this illustration in the left image. We have a person ride on a horse. RCNN extract 2,000 button up region of proposal from this image. Its region in this warp fit into the CNN to compute the feature with a subsequent classification. Using class specific linear SVM is a highlight. However, RCNN has a downside. It's computationally expensive and slow, require a multi-step of the computation, feature injection, classification, and bounding box regression. Is a limited lab of the developed was fast CNN and faster CNN. So, unlike RCNN and variant yellow doesn't reply on recent proposal. Instead, in predict boundary box at the class probability direct from the full image for the single forward pass network time yellow equivalent. The left image, yellow right divide the image into grid. Each grid shall predict number of bounding box at the well confidence score and class probability math. The network can use information to determine which object present where they are located. The single source multi-box detector take different approach to real-time object detection by predict object at the multi-scale using different feature math. This allows SSD handle both small and large object more than efficiently than yellow. Yellow use single grids for prediction. As that use feature math at different resolution. This approach increases the accuracy for object and various size, making it well suitable for tasks like automation system. In the middle and the right image, you can see how SSD evaluate feature math at a different resolution, giving this more flexibility in detect object and the different scale. Detection transformer was introduced. Transformer model in object detection offer simplified and direct approach using transform encoder decoder architect to predict bounding post and classify label directly. In the input in the first pass to CNN backbone for the positional encoding, the transformer decode tag object required and then pass the prediction head to produce the final boundary box and object classification. In the last image, you can see how the two birds are detected in the bounding box. DETR greatly simplify the object detection pipeline by remove the need for the anchor post origin proposal for the non-maximized suppression. This leads to more end-to-end approach, but it comes with some challenge. So we summarize the pros and cons of deep learning. High accuracy. Deep learning model consists on accurate state-of-art performance. Generalization, this model are capable handle wide variant object type and complex sense making them adaptive across different environments. Real-time performance. However, there are some significant challenges. Computational requirement, train and run deep learning model require high computational resource, often involve powerful GPU and large-scale hardware. Large dataset deep learning model often require extensive dataset to achieve their high accuracy, which can be difficult to expensive to collect. Training time, particularly more model like DTR training time is very, very long, making it hard to iterate quickly. First, classification. Classical image processing with the domain pre-2000 led to round out modern object detection technique like candy, templates, and then move to machine learning for accuracy, more improved more accuracy and efficiency. Finally, deep learning from 2010 to present. Some models use yellow 10 as a DFT, swing, transformer, VIT. So now looking forward, a brief discuss of some emerging trend that's a SAF feature object detection. First, we have a supervised learn. The approach allow the model learn unable label. You know, in the past, the human don't know what is it. So now they learn, and now we have some concept we use try to develop this new model. And next, the large scale transform model to present another critical different transform the ATR limits to need the recent proposal simplify detect a pipeline for become large and more powerful. And we also advance for real-time multi-object tracking for a smart city, society fine. Lastly, is right AI for object detection will have significant impact was object detection model for deploy for act device like drone or smart camera, like time process, and cannot kill without cloud dependency, enable faster than more scalable. And finally, is my opinion, 5 years later or 10 years later, quantum computer and quantum machine learning to help object detection more faster, more accuracy, better than. So this thank you for your attention, and we take time to listen to this presentation. I hope my presentation provide value insight into the evolution of and the future trend of the object detection. Thank you very much.
Thank you so much, Professor Bao. It was very interesting. So now we will move to application in the industry of all this technique. What is very interesting in what Professor Bao explained to us is we can see we have a lot of different models. Why we have also a lot of different models? Because as we will see in our use case, how we can apply object detection in smart retail, manufacturing, and other industry, is we have different needs. Sometimes you will need a very high accuracy, but you can accept low speed. Sometimes you need a very high speed in terms of detection, but you can accept more errors, so a lower accuracy. Sometimes you need both. Sometimes you need multi-object detection, or you need to detect complex shapes. And sometimes you just need to detect simple object, simple shape, simple color. So that's why it's very interesting that today we have a lot of different techniques at our disposal because we can apply this different technique to different use cases. So let's deep dive into this use case with our first example. So here in smart retail, you can see exactly what we speak about when we mention multi-object detection. We can detect people as soon as they enter in a shop, and we can detect in real time what they are looking at, what they are picking in terms of object, if they are putting back the object on the shelves. So after, thanks to all this information, we can build what we can call a heat map, where we can see where people spend the most time, what they are looking at in terms of product. So after, it's very interesting in terms of marketing, because it means when you want to do advertising or when you want to promote some product, you know exactly where you have to put them, because it's exactly the spot, the hot spot in your shop where people spend the most time. Another very interesting use case after smart retail, it's in a warehouse management. This, as you can see in the case of warehouse management, I put one image where we have a simple line to guide some robot. It's exactly how a warehouse from Amazon is working. Everything is automated. So here you can see that in terms of application, we do not need any more multi-object detection. We just need to follow a simple line and to activate some task like loading and unloading on very specific spot. So here it's very interesting because you can imagine you can automate from the truck that delivers the product until you can store everything in your warehouse. And after, when you have another truck that wants to deliver these goods, you can automatically prepare everything without requiring human interaction. So not only you save time, but also you can avoid mistake because this kind of warehouse system is connected, of course, with your inventory. So we know exactly where are the objects. So the robot will pick exactly what you want to deliver. So you avoid some mistake. Everything is automated. And of course, it can run 24/7. One use case that we see more and more for object detection is safety. Safety, why? Because thanks to object detection, you can analyze, for instance, I will show you some example in construction site, if maybe you have humans close to machinery, so it can create some danger for them. You can also inspect some facade inside some building to see if any damage. So for instance, on this image, you can see we can detect if there is a barricade. So we can ensure the regulation and safety, of course, for human. Another use case very interesting is facade inspection. As you know, a few weeks ago, we had a typhoon in APAC. So the question is how you can evaluate the damage, in particular for insurance company. And thanks to drone and to object detection, of course, you can inspect automatically and you can have a very accurate evaluation of the damage or of any issue that could appear. For instance, in Singapore, you have some initiative to inspect automatically some building to preemptively anticipate any mistake and fix the building if needed. So here, strongly related to what I mentioned just before in terms of safety, it's also quality control. As soon as you are in manufacturing, quality control is a big issue. As you know, we have some machine, of course, to detect quality, but it's mostly human related, where a human needs to take the object, put the object on a special machine, and after with some laser, they can detect if any defect. But now with object detection, you can plug directly the quality control on your production line. So it means it's more automated than before, more accurate, faster. So in the end, you can check the quality of your production much easier and much faster than before. Another very interesting use case after quality, it's farming. So in farming, it's as you know, we have more and more debate regarding pollution. We can see that farming changed a lot. In Europe, it changed widely since 200 years, and we can see also, for instance, in Vietnam, it's changing. We have more and more tools to produce more with less people. But for a long time, people had to use a lot of chemicals to achieve the growth that they wanted on their field. So now more and more we can see some very interesting use case in farming. So for instance, in US, in some huge crops, they start to use not anymore chemicals, but they use a machine with computer vision that can analyze which weed they need to destroy. And after, with a laser, they target this weed exactly and precisely, and they can destroy like this all the bad weeds on the field. And in the end, we don't need to use any more chemicals, which is much better. Another use case is in the case of disease on plant. What is difficult for farmers, because they are not specialists of all the disease, is when they detect a disease on a plant, either they have to call an expert who come on site and can provide the best solution, or once again, they will use what we call large spectrum chemical, meaning it's a chemical that will kill not only this disease, but a lot of other disease. So you can imagine, again, in terms of pollution, it's not efficient, and also it can damage the plant without knowing. So that's why now, thanks to computer vision, we can not only detect the disease on the plant, like you can see on this image, but we can detect which kind of disease, and after do recommendation to the farmer to say, okay, this is this disease, you need to apply this kind of chemical or this kind of technique to fix the plant. So as you can see, we have really a lot of different use cases that we can apply. And as you can imagine, it's not the same model that we have to apply in each use case. So that's why when you want to apply computer vision to your industry, you need to think also in terms of challenges and what you have to consider. As Professor Bao mentioned, we can achieve today, thanks to YOLO and even a newer model, we can achieve real-time detection, we can achieve accuracy, high accuracy, and we can achieve multi-object detection in real time, but it requires a lot of data and large data set, high quality data set to train this. So it means that when you want to start an initiative around computer vision, the first thing you need to ask yourself is which model will fit my needs? Do I need multi-object detection? Do I need high accuracy? Do I need high speed in terms of detection? Or can we settle for something more modest if it fits your needs? And depending on the answer, you need also to ask yourself, do I have high quality data set to train this model to achieve what you want? One also challenge that you have to take into account is integration. As you know, for instance, I have shown you an example with smart retail. The main difficulty with smart retail is how we can integrate new technology like computer vision in a shop, or let's say in an industry that historically is what we can say a little bit low tech, with a very low adoption in terms of new technology. And hopefully, thanks to the model that we have and the new technique that we have, we can use object detection on basic CCTV camera. And since usually in smart retail, for instance, they got CCTV camera because of safety and because of security, we can plug this kind of system easily. But in other domains, like manufacturing, you really need to think how you can integrate this kind of system in your environment. And that's why we can see lately a trend to merge computer vision and RPA. So it's really RPA, it's how you can automate thanks to some robot. And so you can imagine some system now where, thanks to computer vision, they will plug directly in your legacy and they will simulate human interaction thanks to the combination of, as I mentioned, computer vision and RPA. So after, we need to discuss also about the cost, and I can see also some question regarding this. So in the Q&A, I will discuss more about the ROI, but for sure, when you want to drive an AI initiative, you need to think in terms of cost. And for this, you need to make sure that this initiative is aligned with your core business. And that's why what we suggest is always, when you want to drive an AI initiative, it must come from the top, and you need to make sure that your stakeholders are fully on board on this initiative and that they understand what you want to achieve and what will be the benefit for your business. And last point in terms of consideration, privacy concern, because so for sure in manufacturing, it's not a main issue, because basically you will put the computer vision mechanism within your factory. But as soon as we speak about smart retail, also in terms of safety and regulation, as I mentioned, where we can inspect public building, you need to be careful and make sure that your system will not be against privacy of individual in public space. So in terms of future trends, before we move to the Q&A, we have to see exactly these 4 points. So first, for sure, as Professor Bao explained, we can see a lot of advancement lately in research, and we can see more and more models who are more accurate, faster, and also who can address a lot of different use cases. We can start to see also, for instance, YOLO, the model that Professor Bao mentioned. This model can be executed also on your phone. So we can see today some model for OCR, so character recognition, but also for object detection that you can start to embed on your phone. And this model start to be more and more efficient. So it's very interesting. And it's connected to the second point, edge computing. One of the main issues that can happen when you want to do computer vision is if you put the system within, let's say, the cloud or quite far from where you gather the data, you might have a high latency between the moment you capture the image, the moment you analyze the image, and the moment you take a decision based on what you analyze and you feedback. So you can imagine when you are in a factory, you need to have the computer vision as close as possible as the source of information. And that's why, as I mentioned before, in terms of AI, we can see a lot of improvement to make smaller and more efficient model that we can build within a device. And so it means that now we can see a smart factory where the computing and the analyzing of the data is as close as possible from the source of information. And of course, with Industry 4.0, you can imagine that between IoT and 5G, we can imagine now to have a fully automated and, let's say, coordinated system between your supply chain, logistic, warehouse, but also, of course, your point of sale. So it means that now in real time, we can anticipate when people buy in a shop, we can automatically pass some order, and after your factory will be activated if they have to produce more to fulfill your warehouse, and after some automated robot, thanks to computer vision, that will be able to load and unload some trucks to deliver to your point of sales as fast as possible. And lastly, something that you have to balance, it's sustainability, because for sure, object detection, as I mentioned, in terms of farming, can help to reduce waste. Also, for instance, in a factory, because you can coordinate and you can really minimize the stock that you have in your warehouse. But all this costs energy. So you have to balance what you save on one hand in terms of waste, how you optimize your resources. But on the other hand, you have more and more energy consumption, so you need to balance these two costs together. So now we will move to some questions. So I see some very interesting questions regarding the foundation to start an AI initiative. So as I mentioned before, what is important is to be as close as possible of the source of information. And to do this, it means two things. First, you need to make sure that your information system can host an AI initiative. It is sure that when you want to host an AI initiative, we are speaking about a lot of new technology, often that will be hosted in a cloud environment. So now the question is how you can integrate your legacy system with it. So it means first you need to think in terms of architecture, technical architecture. How do you want and how can you integrate your legacy system with the AI that you want to build. First point. Second point, as we discussed before, we need large data set. So for this, you need good quality data and you need to have a foundation in terms of data integration and data governance. If you do not master your data on your information system, if you are not able to build high quality data pipeline to feed your AI system, you cannot succeed with your AI initiative. So really, the first point to think also is how are you, let's say, educated in terms of data in your company? And usually what we recommend is always to do first a data assessment. What is your maturity in terms of data governance? Then we can move to AI part. So after I can see one question, how to start. So it's exactly this and it's connected. So the first starting point should be business. What do you want to do? As I mentioned before, you need to be aligned with your stakeholder, meaning doing an AI initiative just for technology purpose will not be successful. What you need is to explain to your stakeholder, okay, thanks to AI, because we can improve the quality, we can reduce the cost of our production by 5 to 10% because we will have less defect, so we can save money. Or maybe because you manage a lot of warehouses and you have also a logistic company, you can explain, thanks to AI and thanks to computer vision, we can automate our warehouse. So it means we can deliver faster to our customer the product that they ask. Then we can increase our benefit by 5 to 10%. So if you can measure in terms of business the benefit of such initiative, then you can start to think in terms of ROI, return on investment. Okay, so I know thanks to AI, I can save 10% today. So now what is the cost of implementing such solution in my information system, considering everything I mentioned before? Legacy system, you need to integrate with your legacy system, data integration and data governance, and of course, how do you integrate with AI? How do you train this AI model? Once you have addressed all these topics, you know the cost of this initiative, and you can compare with the benefit in terms of business value for the company. But it's not enough. One more topic that you need to think about is what is the cost of not doing it? Because as you know, the world in terms of business is more and more competitive. We can see more and more exchange between countries. We can see more and more import and export agreement between countries. So it means the competition now can come from everywhere and from any country. So the question you have to ask yourself also is, if I don't optimize my production, if I don't increase my quality, if I don't use more efficient system to provide higher quality services to my customer, what is the risk in 6 months, 1 year, or maybe just tomorrow? What is the risk to see a competitor I did not expect suddenly do better than me? And here, in terms of ROI, it's often more difficult to evaluate, but you always have to think about this. It's not only a basic ROI, what it will bring to me in immediate value compared to what I have to spend to do it. It's also what is the cost of not doing it, considering that tomorrow you can have someone who will do better, cheaper, and faster than you, because since the beginning, he will have automated everything. And here I believe it's very important to think in terms of competitor analysis, how you are sure you can outcompete your competitors. So I can see other question. Can we automate everything thanks to AI? So often for me, the question is not can you automate everything? Because I believe the answer is most often not yes, but close to yes, at least in many domains we can automate. The question is, should you automate everything? Once again, you have to consider the risk. So as we discuss, imagine, and we have seen this recently in the industry, but AI today is not accurate 100%. You can still have some mistake, you can still have some errors, and you can still have some decision that you cannot explain, and that can be very bad for your company. So if you think, I want to automate everything because I want to remove all human decision from the process, it can lead to very high risk for your company, because it means in the end, you don't master anymore the process in your company. If everything is automated and no human can validate this, in the end, but it means AI can take a decision, but you, as a business owner, legally, you are still responsible. And so you will end up being responsible for a decision that a computer take for you. So you have to balance carefully against this. If you want to automate everything, the question is, okay, if something goes wrong, what will happen? What will be the legal consequences for your company, for you also as an individual? So I will take one last question. It's a very interesting question. We can see if object detection can address the intrinsic nature of the object it detects. It's a very interesting question, because it's also related to a debate we have with large language model, which is a basic question: does AI understand the world around it? Because for sure, the question is, when a model detects a horse or a dog and cat. You remember one of the first use case for computer vision early 2000 was, can we classify dog and cats? And AI can do it very well. But the main question is, does the AI know what is a dog and what is a cat? And I believe the answer is no. It's exactly, if you know Professor Feynman, he was a Nobel Prize in physics. He did a lot of things in terms of quantum theory. And it's exactly what he explained. It's not because you know the name of an object that you have the experience of this object. And today, computer vision, basically what they do, they put a name of the object on the object. So it means they don't have the experience of this object. However, and that's why, as you can see, we are moving towards what we call AGI, artificial general intelligence. It's what, for instance, OpenAI try to push. We can achieve this experience of what is a dog and what is a cat thanks to what we will call a multimodal AI, meaning it's an AI that is combined not only with computer vision, but also with NLP to understand when people speak, with also, for instance, why not some generative AI to produce some content, another image, text, but also with audio transcription to understand the world thanks to the sound, but also thanks to sensors to be able to touch and to have more data. I don't have the exact number in mind, but if you compare the number in terms of gigabyte of data a human brain can process compared to what an AI can process, the human brain process much more information than an AI at the same time. Why? Because we got our touch, we got our eyes, we hear, we can smell also. And in AI also, we can start to see some system to detect the smell. So to answer to the question, computer vision, no, cannot address the intrinsic nature of the object, but a multimodal AI combining computer vision, also, sorry, generative AI, plus a knowledge database, plus some sensor, and a multimodal AI who have been trained to apprehend the world and to gather more and more knowledge according to different channels from the world, yes, it will be able to address the nature of the object it detects. So I can see one last question. So since we want to be on time, it will be our last question. The question is, in terms of healthcare, can object detection improve remote patient monitoring and telemedicine? The answer is clearly yes. I don't know if you follow the news, but recently we have seen this. An AI model was able to detect breast cancer for women 5 years before the best expert could do. So it means today, thanks to AI, we can anticipate disease detection, in particular breast cancer for women, 3 to 5 years before existing technology. And as you know, as soon as we discuss in terms of cancer, the earlier you can help people, the better it is for them. So it means it will be possible now to have some center in terms of where they will just have the machine to analyze, to take a snapshot of you, of your body, of your breast, if we speak about breast cancer. And the image can be treated remotely, why not, or even locally, as I mentioned before, thanks to edge computing, because we will be able to put such model nearby. So that's why, yes, in terms of healthcare, AI is of huge help, in particular in computer vision, because as I mentioned, now you can give an X-ray directly to a model, and it will analyze and provide better feedback than a human can do. So thank you all for this very good question. I hope I answered clearly to everything. Thank you all for your participation in today's webinar. We will continue our series. Today was the first episode, and we will have other episodes with other experts. So thank you again, and see you soon. Thank you.